Hey guys, it's Kelly from Keltrack Innovations here. Today I'm going to make a quick video to go over troubleshooting noises with your vertical links on your GT500 Mustangs. More specifically, this is a set of Cortex Racing vertical links for a 2020 to 2022 Ford Mustang GT500. These are the specific set that I use on my personal cars, and this is the only set that I recommend to my customers. Recently, a guy on Facebook made a post about having some that were noisy. I said, hey, shoot them over to me. I'll figure out what the problem is. You know, let's take care of it. I'm not charging him. And I figured it'd be a great time to make a video because so many people use these. In my honest opinion, I like the dual bearing design. I like the machining. I like everything about the Cortex design. I like the clearance, the engineering behind it. It is by far my favorite design. Before I go too much further into this, let me show you them on my personal car. So this is how they mount. They connect the lower control arm in the rear to the outer knuckle or spindle assembly, whatever you want to call it. This is a little bit different than the GTs. The GTs went from here to the top up here, okay? So the way that the whole purpose of this is to control the rotation basically, and then offer some pivot movement. So it'll move like this when the suspension travels, but when you're like racing or accelerating, this assembly will spin, or I'm sorry, the force will try to turn, and then it goes through this. So that's what transforms, transfers the energy right through the suspension. So on the GT, again, it's up here, so the knuckle will kind of push up and down and then put that load into that arm here, where this way they redid it, and it's pulling basically. So when this does this, the energy is pulled on that control arm, not pushing into the control arm. I've got a couple theories on why I think this is a lot better. I'm not going to get into that. Also, an FYI, I learned this 7 years ago on the S550s. The shorter vertical link actually is really good for less toe change during bumps and stuff. So just a little FYI there. When you shorten this up, you have a more stable alignment during hard loading or corners, etc. Let's get back to the table over here. So customer sent me these. I wanted to go over the basic design of these and then go over troubleshooting. So here we go. So first of all, if you're having a noise, you get these off. And just to rewind a little bit, if you have these and you're watching this, take them off once a year, clean them up. I'll show you some stuff, some tricks and stuff. But here we go. I have not even looked at these yet. I just took them out of the box. So they're a dual bearing, so it's a spherical bearing here, spherical bearing here, spherical. No poly, no rubber, nothing. There's no binding, there's no polyurethane deflection. This is just what it is. The only thing it can do is it can pivot like this, okay? And then it can slide like this, like when the suspension's moving up and down, these can turn a little bit. So Cortex is always very high quality components. I don't know what brand bearing they use in here. If I had to guess, it would be an FK bearing or an Aurora bearing. Those are the two bearings that I prefer personally. I'm a bearing snob, so I assume Cortex is using something like that. There we go, look. So the way this is configured is it mounts in between ears here, and then it has a single shear bolt design here that goes into the bottom of the knuckle. That's why it's beveled like this, so it locates it. So the very first thing you're going to do is you're going to, a bearing should really kind of pivot like this, right? So the first thing you're going to do is you're going to try to look for movement. There's no movement there, with a little bit of force. You don't have to try to go crazy. So the second thing is, okay, well, the bearings, if there's a noise, it's either seized, which means it's overly tight and it has contaminants in there, and when it rotates, it'll make like a grinding, popping noise. Or, I'm not bashing anybody here, but the machining tolerances could be off a little bit to where, keep in mind these manufacturers have to try to have a really tight tolerance on the machining of the part to compensate for tolerances on the bearing side too, because a bearing has our outer race and it has to go in here. So without further ado, let's tear into these things. So there's no sloppy bearings here. So the next thing I would guess would be the tolerances. So these bearings may wiggle. One of these bearings or all of them might rattle, and that could cause noise too. So we're going to take these apart. You can feel the quality. This looks like maybe 303 stainless. I really like Cortex because they do make some quality parts. You can tell this is driven on a lot. There's a lot of dirt in here. To touch on the quality, there's a very tight fit, very, very nice design here. You can see down in there that, you know, the machining is good. These probably don't bottom out before touching, so that's good, so they won't rattle. This person, you can tell, drives the shit out of this car, right? That's pretty nasty looking. So first, right out of the gate, we know that these are used. This isn't a car that just sits. If I were to go show you mine on my car that has like a couple hundred miles at the most on it, they would look brand new. So we take this one off here. It's very tight, so that's, again, good quality on both ends. Real nice design here. Real quick, the other noises, if a bearing is loose and this moves really easily like this, you can get to a point where this moves in relationship. Well, actually, right now, see how it's curved? Well, if you reach the end of your travel, and sometimes if the part's not designed properly, etc., this can hit this, and it can cause noises like right here and stuff like that. So that's another thing that can cause noise. But anyways, so we take these off, and here you go. That's pretty dirty, right? So what happens real quick is that the contaminants in there will try and eventually work their way into that bearing race, and it can cause some significant noise and binding issues. So let's flip it over. Now we see, you know, these are out. These are different sizes, by the way. I think it's an M14 and an M12, so you got to kind of keep them together. This one's here, this one's here. They're the larger holes. Now we have a bare vertical link, and this one on this side you can also see all that dirt. So again, these are used. If it's making noise, then it's kind of the nature of the beast. That's why you take these apart. Oh, all right, that was going to be my next test. There we found his noise. So, and we haven't looked at this one yet. So here you go. If you take everything that's loose off and you shake it, and it makes noise, you automatically know, it's right there, it's in that end. You automatically know it's rattling at all times. That's your issue. So this bearing right here, yep, I can feel it. You hear it? Now just imagine that constantly while you're driving. So in this scenario, it's simply just a tolerance issue. Not a big deal. I doubt it's been doing this the whole time, but you guys got to keep in mind, this is a hardened steel, like I think it's probably a ball steel they call it, or like a 5200 series. It's been a while on the engineering side for material stuff, but it's a hardened steel, and it's probably a 6061 T6 tempered material. Cortex guys, if they watch this, they can chime in. Maybe it's a 7075, but seeing how it's kind of softer looking, I would say it's probably a 6061. So this one right here, there's nothing wrong with the dirt. There's nothing wrong with anything else other than right when I picked it up, it started rattling. So that needs to be repaired. The next one, we already went through all this. Take it apart. Take it apart. So now we have another bare one. This one also rattles. So we don't really have to troubleshoot. A little bit there. Yeah, I mean, I can feel the tolerance. See what this one is. Not really. So on both of these, basically, that end, that end. So both of these two ends right here are a little loose. Now, if you look close, you can see like an air gap there between that spiral lock, that's called. It's not a snap ring, it's a spiral lock, which, real quick from engineering standpoint, very good design here. It covers the full surface instead of having like a gap here. In these cars, we're making 1200 horsepower and stuff. You really want a really good part design, right? But again, I mean, we found it. It's that. So this customer's issue is these two bearings right here. Now, I'm not gonna get into the repair process. I'm happy I found this for the customer really quickly. I assume he's gonna send these, or I'll send them from here straight to Cortex. There's a couple things going on here, so let's talk like engineering, tolerances. All right, so if this is a little loose and it's loose enough, I'm trying to get it on film where it's moving up and down so you can see it. It's kind of hard to make it focus well enough. But if it's loose enough to move up and down when they're sitting like this, there's a couple things you can do. You can take this apart, and then you can make some, you can put some real thin shims in here, and then you can make it tight. Hold on one second. You can make it tighter. So yes, the tolerance on the OD and the ID here, inside here, may be a little sloppy, but it's not like it's super sloppy. I mean, when I do this, it's not like it's clanking, okay? Like this way or this way. It's just sloppy enough for this bearing to move in and out. Now there's two ways you can look at this. You can look at that it's not a press fit, but they're relying on pressure from the spiral locks. Or you can look at it like they wanted to press fit it, and this is just holding it in for safety. So there's a couple different ways. There's a couple different ways you can look at this. In my honest opinion, the tolerances aren't sloppy enough to where you have to add material in here and then get this tight. In my opinion, you could just fill that little void up with a really thin shim on the bottom or the top, and it would fix your issue. Let me see this real quick. Yeah, so it's literally just enough movement to make a noise. It's not enough, I don't feel like side to side and stuff like that. I don't feel anything that would shock load this part to damage it. Cortex could say otherwise. But overall, like I said, we found the issue. It's a tolerance issue. This could also be why I think Cortex requires red Loctite on assembly, or maybe they used to when they would send them out. I don't know how that works. I know on their engineering sheets and stuff they talk about putting Loctite on the installation of the bearings, and maybe this could be why. Maybe these had like a green or a super high strength Loctite, and all it did is over time it just kind of came loose. I'll be interested to see what the customer has to say about this, or what Cortex ends up doing for him, or if they do anything at all. I mean, this is high performance stuff with 1,000+ horsepower cars. The customer that sent these in has a Whipple on his car. He makes a lot of power. He apparently drives it. At some point, you can't rely on these companies to honor and keep parts alive for the lifetime, right? So at some point, these are service items. This is a bearing. It's made for competition use. Technically, it's not a bushing that's just going to be cushioned and last forever, anything like that. Again, I'm going to get with the customer, show him this video, and then we'll go from there. If Cortex has any input on this, maybe when I post it, they can comment and just talk about it a little bit. I just wanted to go over it. It's pretty cool that we found the issue this fast. We know exactly what it is. Again, the other things that can happen. Oh, I had this out on purpose. I was guessing this would fit. Okay, perfect. So what I was gonna do if we didn't have this tolerance issue, which I'm sold that that's his noise, the next step would be to put something in here and then move it, right? So, okay, yeah, that actually, I can do it with one hand. That's impressive. It's a nice firm movement. So that's what I was gonna say, is our next step would be to rotate this and then see, hold on a second. Let me set this up like this. So the next step would be to move this in a manner that tests if anything's bound up. So I did the one, I just flipped it around to another one. They move very nice and smooth. So the race to the ball here, the relationship is probably a Teflon or a Kevlar liner in here. The relationship of this ball to the outer race is good. It's nice. It's not focusing very well, but it moves nice and smooth. I wish I had a bad one here. I'm going to test this other one. I wish I had a bad one. Shit. I wish I had a bad one here so I could show you kind of what happens. Nope, this one's good too. So again, they're using a high quality bearing on these. No noise, no binding, no ratchety feeling. So that's good. So I'm under the impression that all these need is maybe a little spacer shim under that spiral lock, clean them up a little bit, and then go. Thanks for watching, guys.